works as a security consultant at Payatu Software Labs, and he loves finding security flaws in the Microsoft Edge browser. And incidentally, this is the topic for this next talk. So please give a big round of applause to Nikhil Mittal.
Yes. So, welcome to the talk, Breaking Microsoft Edge Extension Security Policies. My name is Nikhil. I work at Payatu Labs, and I'm into web and browser vulnerability research. So, to start with this presentation, I would like to know how many of you uses browser extensions in general? Like, oh, nice. So many hands. Okay, so a browser extension is something that extends the functionality of a web browsers. We have a typical examples like AdBlock Plus, which I think most of the people uses to block the ads on some certain sites like YouTube, and Grammarly, and some sort of password managers as well. So these extensions are capable of managing most of your data because they can handle the cookies, bookmarks, storage, passwords, history, and whatnot. So that being said, we all have to agree on a point that these extensions are powerful because they can deal with your cookies, bookmarks, and other sensitive information in the browsers. So here's how simple AdBlock Plus extension looks like on Microsoft Edge, which is pretty much doing its job. Now, have you ever tried to figure out what this extension is capable of doing in your browser? Oh, nice. So if you look at the settings, here we have a couple of permissions, which I've listed down on the next slide. So a simple AdBlock Plus extension can read and change content on websites that you visit. It can read and change your favorites. It can see the websites you visit. It can read and change anything you send or receive, and it can also store personal browsing data on your browser, and it can also display notifications as well. So there are so many things a simple AdBlock Plus extension can able to do in your browser. So you might ask, like, how browsers recognize these permissions? Like, an extension is able to do so many things in my browser, but how does browser recognize, like, where are these permissions coming from? So here's a permission model in browser extensions. So under the source of every extensions, we have a file called as manifest.json, and inside a manifest.json file, we have a permission array. So here's a quick example of a permission array where we have some permissions. So the first one is https www.google.com, which we'll see right after this slide. The next permission we have is bookmark, and cookies, history, storage, and tabs. So let's suppose a extension has a permissions with the bookmark and cookies. So that means that extension can handle your bookmarks. It can manipulate them. It can edit them. It can remove them, and whatnot. So the same goes with the cookies, history as well. And there are other important permissions as well available for the browsers. So apart from these permissions, the most interesting permission that I was looking for is the host access permissions. So a host access permission is something that defines on which certain domains your browser extensions should be able to run. So in this case, let's suppose we have assigned permissions to http www.google.com. So that means this extension should be able to run on google.com only, not even the subdomain, that is developer.google.com or mail.google.com. So this you can also verify with the tiny box that says this is allowed to read and change content on some sites, www.google.com. Now, the second permission we could have in this here is http://google.com. So basically this also covers the subdomains as well. And the third possible permission we can have is *//*google.com. So basically this says now not only I'll work on google.com, but basically on all the protocols as well, which is HTTP, HTTPS, might be FTP. That belongs to the particular domain. So apart from these three permissions, we have the another permission in the row, which is all underscore URLs. This permission is so special because once a browser extension is assigned to all underscore URL permissions, that can execute JavaScript code on every domain that you visit. So let's suppose you are on google.com or maybe you're on bing.com or anything else, it will work on most probably on every domain. But there are a few restrictions with the all underscore URLs permissions. That is, it cannot run on privileged pages. So a privileged page in browser is something that contains some sort of sensitive settings and your browser data. So you might hear of Chrome/ls settings, which contains the password manager for Chrome, and also you can identify the credit card and debit card information on Chrome/ls settings as well. So you can imagine a situation once an extension is able to run a JavaScript code on Chrome settings page, then it can probably read or it can steal all of your passwords and credit and debit card informations as well. So on the edge, we have a similar page, which is about.flex. So here you can see once an extension with all underscore URL permission is assigned, it can read and change content on website you visit as per the edge. So here's a quick snap of about.flags in edge. And so if you look at the first part, you will figure out there are a few important permissions, like you can enable Adobe Flash Player. You can also enable developer features. And also you can enable and disable allow unrestricted memory consumption for the web pages as well. And it also has some standard previews features, like you can enable, disable some experimental JavaScript features as well. So now you can imagine the sensitivity of this page contains. Okay, so let's quickly build the extensions. So that will break most of the things in Edge. So as I said, every extension has a manifest.json file, which has all the permission and other configurations. The second file that we will be needing is popup.html. So popup.html is nothing but it's just an interface for the browser extension. So basically you might have noticed as soon as you click on any of the browser extension, a pop-up appears on your window that contains some sort of functions. That is nothing but just a popup.html file. And then again, we have a popup.js, which has all the JavaScript code that executes according to the actions chosen by the popup.html. So this is how our extension should have looked on the edge. So you have seen a tiny Microsoft logo. And as soon as you click on it, a pop-up will appear which says, I'm the evil extension. And I have two options. The first one is open. The second one is execute. So as soon as you click on the open button, what it does is it will load google.com on the browser. And as soon as you click on the execute button, it will just alert one for you. So basically the interface is written in popup.html. And again, as soon as you click on execute, so the work is done by popup.js. So let's quickly look at the source code for the manifest.json file. The thing to notice here is that you can figure out the permission array on line number 10, which is set to http://www.google.com. That means it's clear that this extension should be able to run on google.com only. I mean, not on the subdomains even. So here's the source code for the popup.html, which is just a simple HTML file that has two buttons. The first one is open, the second one is execute, and it has a popup.js at the end. So here we have the popup.js. So in very brief manner, what it does is as soon as you click on the open button, it loads google.com. And as soon as you click on the execute button, it calls the JavaScript. It alerts document.domain for you. So there are so many APIs available for the browser extensions that you can use. Like history API and some sort of proxies API, tabs API. But for me, this tabs API was so interesting because it allows you to play with different tabs. Like it has some function methods inside, like tabs.create. So what it does is it allows you to create a new tab with any arbitrary domain, and it also has tabs.update. And what it does is it allows you to update the page with the next URI. And tabs.duplicate is also important because it allows you to make an exact replica of a already open tab. The next method is tabs.execute script. So this is pretty simple. This is allowed you to execute JavaScript code. And tabs.hide and tabs.relate, which is pretty easy. So, and there are so many other methods as well. So out of them, the most interesting one for me was create and update, and also the duplicate method. So let's see if you want to load a new, so let's see if you want to load bing.com on a new tab using a browser extension. So you can just write this 5 lines of code that calls browser.tabs.create, and then it passes a URL which is https www.google.com. So this is as per the documentation, and this is for the good boys, like not for us. So as an evil mind, like I was interesting to know like what would happen if I try to load local files instead of a normal domain. So then I replaced the Bing URL with a particular local file URI to try to figure out like how browser will treat it. Will it open it or not? So the next moment, Edge gives me this nice error like, okay, I can't reach this page. And you make sure you have got the right web address, that is ms-browser-extension, and then the path for the extension, and it appends the file URI path in the last. So basically, Edge assumes that this is a relative path, and I'm going to add it with the extension path, and I'm going to try, and I'm going to open it. So since that particular part doesn't exist, it gives us an error. So this is not a thing with the extension as well, but this is a journal. Like any of the browser, they don't allow you to load local files at any cost because this might lead an issue to steal your local system's files. So you can see the image in the Edge and Chrome browsers. So here I'm trying to load local files using the JavaScript. So every time it says, okay, we are not allowed to do that because we care about our users and we will protect them. So since we figured out this browser.tabs.create method was not working for us, the next method that I was looking for, the update. So I tried the same thing with the update method, and somehow it worked for me. So next, once I figured out, okay, now I can load the local files. Now I want to load the privileged pages because they are also interesting for me, and it was also working fine for me at the moment. So here you can see, as soon as you click on the open button, browser loads a local file for me and also a privileged page on Edge. So I've reported this bug to Microsoft, and they quickly responded back to me saying we don't support download API, so even if you load the local files, you have no way to steal it. Like you literally cannot do anything by loading the local files, and we are not going to fix it. So I said, okay, let's do it another way. So the next moment, the idea came to my mind is to use the JavaScript URI. A JavaScript URI is something that starts with the JavaScript protocol. It has a particular syntax, like first JavaScript, and then colon, and then the JavaScript code. Here we have a simple examples, like as soon as the ahref JavaScript :alert1, it gets rendered in the browser, and you click on the test, a JavaScript code will pop up on your browser. So the good thing about the JavaScript URI is that they executes in the main domain's reference, unlike the data URIs. So you can look into the image. We have JavaScript URI and the data URIs as well that points to alert document.domain, and one JavaScript URI says I'm on html.squarefree.com, while the data URI says the null domain. So basically, the data URIs was supposed to execute on the main domain's reference a couple of years back, but then it creates a lot of mess with the browsers. So browser vendors, they decided to execute in the null domain reference just to make it too safe. So at this point of time, I decided, okay, JavaScript URIs are like the best candidate for us, so why not to try it? So I've tried the same JavaScript URI with browser.tabs.create, and again, it doesn't work for me. But again, we have a friend called update method, and I've tried the same thing with the JavaScript URI that points to browser.tabs.update, which again calls JavaScript::alert document.domain, and it worked for me this time. So you can figure out with this picture, this extension should have able to run on google.com, and now we are on a bing.com, and if you click on the open button, we have a JavaScript code execution on bing.com. Like, this is how bad it was, because that's a total violation of the privacy, because the user believes that this extension shouldn't able to run on the other domain except the google.com. So this was again reported to the Microsoft saying, okay, so in the last time I've reported like I'm able to load the local files, but you said I'm not going to fix it. And now we have a JavaScript code execution as well. So then again they said, okay, like we got your concern. We understood what you're trying to say, but can you also alert users' cookies as well? Like, is it possible to steal the user's cookies? Then I said, okay, why not? So instead of document.domain, you can just use document.cookie to pop up users' cookies as well. So since we have